A4 paper is built around root 2, about 1.41. So why does your printer trust it? That number never settles into a final decimal. Yet it quietly shapes the page sitting in almost every office printer. The same shape shrinks, grows, folds, mails, and stacks without changing its proportions. The mystery is why an office standard begins with impossible precision. A4 is not merely 210 by 297 millimeters. It fits the tray because the machine was built around the same rectangle. It fits the envelope because the envelope system inherited the same logic. It scales in design software because the next size is mathematically related. Most people meet the system only as a boring drop-down menu. A 3, a 4, a 5, and the rest sound like labels. They are really instructions for cutting a rectangle again and again. The rule is invisible until a sheet becomes smaller. Nearly all countries use this office standard, with North America as the famous holdout. So the real question is not what size paper is. The lazy answer is that bureaucracy picked a neat rectangle. Another answer is that a 4 is basically North American letter, but letter is wider, shorter, and shaped by a different ratio. Letter is about 216 by 279 millimeters. A 4 is about 210 by 297 millimeters. Letter covers about 60,300 square millimeters. A 4 covers about 62,400 square millimeters. So the mismatch is not a typo. It changes forms. Trays, envelopes, margins, binders, and old files. Convenience is real, but it is not the origin. The origin is a rectangle that survives being cut in half. The system starts with A0, defined as exactly 1 square meter. Its shape is locked to root 2, about 1.41. Cut that rectangle across its long side, and the halves keep the same proportions. Cut again, and the same trick repeats. A 0 becomes A1, a 1 becomes A2. After 4 halvings, you reach A4. Mathematically, A4 should occupy exactly 1/16 of a square meter. That is 62,500 square millimeters. This is why the name is not decoration. The label tells you how far the sheet sits from the starting sheet. At 80 grams per square meter, a single A4 sheet weighs about 5 grams. That turns a stack of pages from mystery mass into arithmetic. It also makes postal thresholds predictable. With a typical 20-gram envelope, 16 A4 pages can sit under 100 grams. The same ratio gives copiers a fixed shrink button. A 3 to A4 uses about 71%. A 4 to A3 uses about 141%. Those percentages are not guesses, they are square root steps. The image changes size, but its borders still agree. No new layout grid is required. No margin rescue operation is required. The idea is older than the copy machine. Lichtenberg described the root 2 paper property in 1786. French stamp law used related metric formats in 1798. Ostwald pushed a world format around 1911. Postman turned the geometry into a national German standard. DIN published that standard on the 18th of August, 1922. ISO adopted the A and B series in 1975. The current formal edition is ISO 216 from 2007. Once standards spread, machines started inheriting the rectangle. Printer trays, paper cutters, presses, envelopes, and forms converged on matching sizes. Paper mills benefit when standard cuts can serve many buyers. Office equipment makers benefit when scaling keys and trays repeat across models. International Paper reported about $16 billion in revenue in 2023. Global paper and paperboard production was about 411 million tons in 2022. But the perfect rectangle cannot be manufactured with infinite decimals. So the standard rounds the math to whole millimeters. A 0 should be exact, but the table lists it as 1189 by 841 millimeters. That rounded rectangle lands just under a perfect square meter. The whole system misses mathematical perfection by about 51 square millimeters. A 4 inherits the same rounding, trimmed to 297 by 210. So the real page sits about 0.2% smaller than the flawless one. The magic is not purity, it is controlled compromise. That is why the holdout problem is so sticky. A different paper shape means different files, folders, trays, cutters, forms, and habits. Status quo bias makes the installed base feel cheaper than the better design. Path dependence turns yesterday's equipment into today's rulebook. A paper standard is a negotiation between math and machinery. Root 2 gives the clean recursion. 1 square meter gives the system a measurable anchor. Millimeter rounding makes the anchor buildable. The page in the printer is a tiny treaty between elegance, loss, and lock-in.